Hello and welcome to today's session. In today's session, we are going to see KNN algorithm, that is K nearest neighbor. KNN is one of the most basic yet essential classification algorithms in machine learning. It belongs to the supervised learning domain and finds intense application in pattern recognition, data mining, and intrusion detection. It is widely disposable in real life scenarios since it is non parametric, meaning it does not make any underlying assumptions about the distribution of data, as we opposed to other algorithms such as GAMM, which assume a Gaussian distribution of the given data. We are given some prior data, also called training data, which classifies coordinates into groups identified by an attribute. As an example, consider the following table of points containing two features. Intuition, intuition behind KNN algorithm. If we plot these points on graph, we may be able to locate some clusters or groups. Now, given an unclassified point, we can assign it to a group by observing what group its nearest neighbors belong to. This means a point close to a cluster of points classified as red has a higher probability of getting classified as red. Intu- Intuitively, we can see that the first point 2.5, 7 should be classified as green and the second point 5.5, 4.5 should be classified as red. Why do we need a KNN algorithm? KNN algorithm is a versatile and widely used machine learning algorithm that is primarily used for its simplicity and ease of implementation. It does not require any assumptions about the underlying data distribution. It can also handle both numerical and categorical data, making it a flexible choice for various types of data sets in classification and regression tasks. It is a non-parametric method that makes predictions based on the similarity of data points in a given data set. KNN is less sensitive to outliers compared to other algorithms. The KNN algorithm works by finding the K nearest neighbors to a given data point based on a distance metric such as Euclidean distance. The class or value of the data point is then determined by the majority vote or average of the K neighbors. This approach allows the algorithm to adapt to different patterns and make predictions based on the local structure of the data. Now, let me demonstrate a Python program in which I have implemented KNN algorithm. Now, firstly, let me execute this particular Python program. Now, let me break down this Python program into parts. First one is import libraries, datasets used to load built-in datasets like the Iris dataset. Train underscore test underscore split splits data into training and testing sets. K neighbor classifier, the class for the KNN algorithm. Accuracy underscore score and classification underscore report used to evaluate the model's performance. Load the Iris dataset, iris.data, the feature set, sepal length, petal length, etc. Iris.target, the target labels species of iris flowers, setosa, versicolor and virginica. Train or test split the data into 80% training data and 20% test data using train underscore test underscore split. A KNN model is created with K equal to 3 nearest neighbors. The model is trained using KNN underscore model.fit with the training data. The model predicts the class labels on the test set using KNN underscore model.predict method. The performance is evaluated using accuracy and classification report. The classification includes precision, recall and F1 score for each class. Now let me also explain the output. Accuracy, the percentage of correct predictions made by the model. In this case, it's 100% because the Iris dataset is simple and well suited for KNN. Classification report, this provides more detailed evaluation metrics for each class. The proportion of positive results that are correctly predicted. Recall, the proportion of actual positives that are correctly predicted. F1 score, a weighted average of precision and recall. It's a good metric for imbalanced data sets. The next point is advantages of the KNN algorithm. First is easy to implement as the complexity of the algorithm is not that high. Adapts easily. As per the working of the KNN algorithm, it stores all the data in memory storage and hence whenever a new example or data point is added, then the algorithm adjusts itself as per that new example and has its contribution to the future predictions as well. Few hyperparameters. The only parameters which are required in training of a KNN algorithm are the value of The only parameters which are required in the training of a KNN algorithm are the value of k and the choice of the distance metric, which we would like to choose from our evaluation metric. The next point is disadvantages of the KNN algorithm. First is does not scale. As we have heard about this, that the KNN algorithm is also considered as lazy algorithm. The main significance of this term is that this takes lot of computing power as well as data storage. This makes this algorithm both time consuming and resource exhausting. Second disadvantage is curse of dimensionality. There is a term known as the peaking phenomenon. According to the KNN algorithm, is affected by the curse of dimensionality, which implies the algorithm faces a hard time classifying the data points properly when the dimensionality is too high, prone to overfitting. As the algorithm is affected due to curse of dimensionality, it is prone to the problem of overfitting as well. Hence, generally feature selection as well as dimensionality reduction techniques are applied to deal with this problem. So that's all for today. Thank you for listening me patiently. Let's meet during the next video or during the next session.